And then this is a lighting fixture. We are using LED lights, and then we are using self-illuminating exit line, which don't use any light at all. I mean the electricity at all.
How does that work?
It's like a self-illuminating. Have you seen like do you fish? You know, when you fish at the night, you use the float with the self-illuminating, bar. It's same concept.
Does it absorb light in the daytime?
That's right. Yeah, daytime or from other artificial light. Yeah. And then our target is like 0.1 watt per square foot. It's really great. And then the John Evans, he asked about, he saw at like 0.7 watt per square foot on the drawings, but I don't know what happened, but we're gonna figure out. But I bet with this LED light, it will be really low, I think.
Typically, with even fluorescent tube technology, what people usually consider good for watts per square foot for light? Typically, it's a lot more than that.
Oh yeah, down to 0.7 or 0.8.
Yeah, so we're an order of magnitude below that.
Oh yeah, yeah. And then also we use natural night flashing ventilation. We have an arc tube on the southeast corner, and it brings natural the air into the building. And nighttime we open up the high window and ventilate. But now we are fully utilizing this arc tube system for cooling, because we are still discussing about the cooling system. So we may have a more arc tube for this building, and so that we can use arcs for cooling, arc block, arc tube, geothermal well. And then we are using solar heating and cooling. And then heating is straightforward, using solar thermal panel, bring down, and use a radiant floor system. And then we can use, compared to the forced air system, we can use a lower heat temperature, so which is more efficient, and it's just heating the body of people, not the entire space, so it's more efficient. And then work really well with thermal mass as well. And then for the solar cooling, we are using solar liquid discant cooling system, which is a liquid discant is like a salt, which can absorb moisture out of air. So first incoming air goes through the discant, liquid discant, it drips on the panel, and the air goes through and absorbs the moisture. And then that one is sent to the regenerator, which heat using solar heat, and they heat the discant material, and then it will release the moisture, and the moisture goes outside. So this will decrease the humidity in a building. So basically, this deals with a latent heat, which is a humidity portion of the cooling load. And then in Midwest area, I don't have Iowa, but like Chicago, Omaha, the more than 3/4 of cooling load is from latent heat. So dealing with the latent heat or humidity is the best way for cooling efficiently. So again, this is a liquid discant system. And then also it needs to chill the incoming air still. So we are using geothermal well, and then chilled water from geothermal well goes to the discant system, and it cools the air itself. Also, when the liquid discant is cooler, it can absorb more moisture. And then also we use a liquid discant storage, which can store more energy, which is only 1/10 of the capacity compared to the hot water storage. So if you need 700 gallons of hot water storage, you can only have a 70 gallons of liquid discant storage, because you are storing energy as a latent heat, not like a thermal sensible heat. So you don't need a huge storage space. And then it's really efficient because it doesn't have the heat pump. It runs only 2 kW for total building system. And then the temperature requirement is only 160 to 180, which can come from regular solar thermal panel. You don't need a high temperature solar system for this one. And then on-site renewable energy, we started with 5 kW over PV and 15 kW of wind, but we are kind of going towards like 10 and 10 system right now. And you can already see some solar panel on top of a utility shed, which is running the construction equipment. So during construction, we are already using renewable energy. And then you can see maybe on the roof, from the side, we already installed the solar thermal evacuated tube system. And then this building is off-grid, so we have a battery. We already have battery in the utility shed for construction purpose, but we're going to have more batteries. And then we're going to have a biodiesel backup generator. It's only for backup, when there is no solar or wind, but it will be rare. I think there is a wind always here, I think so. Like an abandoned eco village, you don't have that kind of situation, right? And then we can even export the electricity to the another building if we have excess of electricity. So this is a kind of energy consumption chart. So it's kind of tiny. It's hard to see, but this is an Energy Star building. And then this is an energy saving from a building envelope. So by building envelope, it goes to half of the energy use compared to Energy Star, which is already really good energy efficient building. And then by daylighting goes down. And then I just put in case for comparison purpose, I put the geothermal heat pump. You can come down to the 17 BTU per square foot per year energy use with a geothermal heat pump. But compared to our solar discount or radiant floor system, there is a 5 kBTU difference, and then which we have to compensate with the PV panels. So that's why we are using solar thermal system, because we can use less surface area on the roof. If we try to do with just PV, we may not have enough roof area just for PV. But fortunately, we have wind, so maybe with the wind, if we have more wind, it's not going to be an issue. But if you're going to just do net zero building with a PV, you got to be careful with the available roof surface area. And then our building goes further. It's beyond net zero. We are exporting energy in the future. Maybe we're going to have an electric car charge station.
This comes from the wind generator, that last column?
Last for both wind and PV, it goes beyond the net zero. So basically, yeah, this is a geothermal comparison. Again, if you use a geothermal heat pump versus our discount system, we need 15 kW more PV panel or wind system to compensate. Also, like a peak, if you have any heat pump system, you're going to have a fluctuation of a peak with a geothermal from 12 kW to 53 kW. It's not a constant energy use. There's a peak. That's why the discount system is ideal. And then if we use earth tube, yeah, it's no brainer. Earth is really stable. So this is our situation. But this is, like a discount system is really hard to analyze using available computer analysis, energy analysis programs. So this is, we kind of fake the system, using a geothermal heat pump and then take the latent heat out. So I think reality, this could be much better than this, I believe. So this is our solar system. So this yellow portion is the solar thermal collectors on the south side, which is that side of the roof. And then on top of this higher corridor roof, we're going to have PV panels, as well as on the utility shed right here. And then this is a kind of optional solar thermal collectors. But if we're going to go with the earth tube scheme, and then we also talked about radiant cooling system, and then having smaller discount system, then maybe we don't need that extra solar thermal panel. So again, the recapping the efficiency of solar thermal panel, we need just a less area for solar thermal compared to PV. So the summary, so we have to see the building design holistically, just not parts by parts. We have to see as an entire building or entire site, what's available and what's the energy used and what is the available roof area. We have to see everything. And then first maximize the energy efficiency. That's the cheapest way to go for the net zero building, especially for the off-grid building. And then also study cost effectiveness between efficiency among the different HVAC system. And then also the study cost effectiveness between energy efficient system and the renewable energy system. And then even renewable energy or solar system, just compare cost effectiveness between solar thermal and PV and the other renewable energy system. And then just check the required surface area of the building. If you're going to do multi-story net zero building, chances are you're not going to have enough surface area for PV panel. So you may need to incorporate wind or maybe micro water turbine or that kind of system. So that's it. Thank you very much.